Coming to the properties of relative velocity or relative speed. See, when we talk about relative velocity, velocity can be positive, negative or zero, correct? Because it's a vector quantity. Now same thing happens, but here what we do is, see, when we talk about relative speed, now two objects has to be in the same direction if they are going, then we subtract it, correct? And in opposite direction when we add it. So suppose, let's say, see, A and B are moving like this, same direction. So speed of A minus speed of B, or velocity of A minus velocity of B. That's the first property. The second property, see, A and B are like this. Now A moves this way, B moves this way. Then velocity of A plus velocity of B, or speed of A plus speed of B, correct? Now suppose if A and B are like this and they are moving this way. Okay, now velocity of A, velocity of B. Now in this case you should not add the velocities. Okay, you should not add it, because see, what happens is, for any relative speed or relative velocity problems, you should always have one frame of reference, we call it. Okay, so frame of reference can be distance, or frame of reference can be the time. Okay, now in this case both distance and time both are changing. So we have two variables but we have only one equation. Can you solve it? You cannot solve one equation which has two variables. Okay, so that's not possible. That's the reason we say that relative velocity or relative speed doesn't exist for such type of questions. Okay, so I can never start with an example saying that point A and point B start from the same, two cars A and B start from the same point, but they move in opposite directions like this. Okay, then there is no relative velocity. Clear with this? That's why the example what you saw in the previous video, both of them are moving towards each other. That's where relative velocity comes into play. Understood, right? Okay, so now coming to how we actually represent this using graph. Okay, now as you can see this is the first graph. You have V1 and V2. Now in this case the relative velocity is 0. That means, see, they are parallel. Okay, they are parallel. Like a simple example I'll tell you. Any object on earth is basically, see, earth is moving, correct? But if you look at any objects on earth here, what is the relative velocity? 0, correct? It's 0. This is the best example what you can give. Suppose, let's say, hypothetically speaking, we go somewhere outside the earth. Okay, then if you see the earth will be moving, right? Every object on earth moves. Alright, so that means you have to go outside earth, which is, that's why hypothetically. But since we are on earth, any object we see on earth, the relative velocity is 0. I see a tree, I see a building, I see a lot of objects, relative velocity is 0. But actually speaking, we are also moving, right? Earth moves with a very high speed or velocity. Okay, so what we say, when relative velocity is 0, this is how the graph looks like. Okay, now the second thing, see, we have two velocities. See, this is V2 and V1. Now they are intersecting at one point, right? Now that point is the time where both of them will meet. Okay, like for example, suppose if I say that two objects are moving in the same direction. Okay, let's say train A is moving at 50 km per hour and train B is moving at 80 km per hour. Okay, now train B and train A, both of them will meet. Correct? They will meet obviously because train B is going at a faster pace. Now both of them will meet. After what time will they meet? Suppose if I ask you, so from the graph we can figure out. See, this is the graph. The point of intersection is the time where they meet. Understood? So whenever we have two different velocities, the intersection will give you the time. If both of them are moving with the same velocity, then you will have two parallel lines. Understood? So these are few properties of relative velocity or relative speed. Clear with this?